Amplify Science, Matter and Energy in Ecosystems, Chapter 3, Lesson 3.1, Carbon in the Global Ecosystem review video. So we're going to head over to the warm-up. And once again, most warm-ups, there's not an answer that I can give you. So here is a memo, and what do you think happened to the carbon? So this is about what you think at the start of the lesson. In step 2, we're going to talk about what possibly happened to the carbon that used to be in the air, or abiotic, the carbon dioxide floating around the air, in the biodome. And if we look closely, this carbon dioxide line is the one that really stands out. So you should notice the carbon dioxide right away is starting to go down. When you compare it to sunlight and water, they're pretty stable. So right away, there's an indicator that something might be up. And by the time it hits the 3rd year, it's really in decline. And this is where they noted it is affecting the plants and animals in the biodome. So whatever's happened there is already enough to start showing up and affecting plants and animals. And by year 5, they give us 2 images of definitely an undernourished cow and producers that have no leaves on them. So significant impact. So you're going to investigate by reading about carbon in the global ecosystem. So you're going to want to click on the link and open the article. And this image is something that's probably fairly familiar. We see it all the time. But these factories burning fossil fuels, releasing carbon into the atmosphere. And as you read through this, it talks about the role of carbon dioxide in the atmosphere and how that traps heat and warms the earth. And that where does this carbon come from? Well, it comes out of the ground as coal. And then it goes into the story of how that coal is burnt for energy, right, to create steam and to fuel turbines. But that coal and anything in that coal family, the fossil fuel family like oil and gas, are generated when plants and producers die and they're trapped and they aren't decomposed, and that coal maintains a high level in the dead material or abiotic area. And as it's buried deeper and deeper and it's compressed more and more, it can then be dug up as coal or pumped out of the ground as natural gas or oil and used as fuel. And in the Earth ecosystem, since it's a closed ecosystem, in other words, stuff from Earth doesn't escape out into the universe and the galaxy or the solar system, and stuff other than maybe small meteorites and things don't come to the Earth very often. Energy can come and go, but materials can't. So that carbon is in this Earth ecosystem all the time, and it's going to show up either in the soil or in the air or in the water. And since it's constantly being cycled, when it's in the ground as fossil fuels, the energy is stored down there, and it's not in the air, and so it's not heating the atmosphere as much as if there was a bunch of it. So as this material is burnt, it goes directly to abiotic matter. In the natural cycle of things, producers and consumers and decomposers are producing carbon dioxide, but nothing compared to massive burning of fossil fuels, in where we tip the cycle from most of it being stored in the ground to much of it being in the atmosphere. And that is obviously causing problems. It's impacting the Earth. So as you read through here, you come to the graph where they show carbon dioxide levels have gone from 320 parts per million to up over 400, and it's increasing faster and faster and faster all the time, as are our temperature trends. And you hear about it in the news all the time about how we're setting new temperature records, and we're getting things like, as you see in the image here, droughts. And so that kind of shows how the carbon cycle is affecting our planet and us in particular. So once you've completed that, you're going to discuss with your classmates, using your annotations, about what you discovered in the carbon in the global ecosystem. And then in step 5, your job is to increase carbon dioxide in the atmosphere in the simulation. So I've opened the simulation, and here it is. Now there's a number of things we can do based on what we know. If we increase consumers, we're going to increase cellular respiration, make more carbon dioxide in the atmosphere. But eventually that'll get cycled back to producers. We could lower the producers. In other words, they're not using as much carbon dioxide in the air. And that way you'll see more available in the abiotic matter. But one of the things, I'm going to start this a little bit so you can see it. I'm going to tie it back to what we learned in the article. What I'm going to choose to do is a couple things. We can bury energy storage molecules. That would be storing the energy in the soil as the fossil fuels over time. But much like the article showed, I'm going to start burning this as fast as I can. I'm going to take all these molecules and burn them up, and notice how much carbon dioxide then enters the abiotic matter. Okay? I can also keep it there by trapping it. If I trap this carbon dioxide, it then is not available for the producers to turn into energy storage molecules. So I can really disrupt this cycle by burning fossil fuels, burning carbon, and trapping it in the atmosphere, and it doesn't allow it to enter back into the cycle. And you can see that the carbon dioxide levels have gone up considerably. I'm going to grab a screenshot of that, and then I'm going to upload the image here and explain exactly what I just told you about how if you release the carbon dioxide and then trap it, it doesn't enter in the ecosystem as energy storage molecules, and therefore it stays carbon dioxide for a considerable amount of time. So be sure to hand that in, and at that point, you should have a pretty good idea of what's going on.